Okay, so let's talk about this. So what do we do if we're trying to solve an absolute value equation like this? An equation that involves absolute values. This is not hard stuff, right? But we want to make sure we get our thinking right on this because we got to follow a strategy. And if we follow this strategy, these are really not difficult. So what do we do first?
Add 1.
Add 1 and then what?
Divide 2.
Divide by 2. Good. What's the purpose of that? What are we trying to do?
Isolate the
Good. We're going to isolate the absolute value. Okay. So that's our first step. We got to isolate the absolute value. Sometimes that's already done for you. Sometimes that requires some algebra to do, right? But it's never really that difficult. Okay, now remember, the other thing that we got to always be aware of is that can we ever like multiply stuff through the absolute value or no? What's inside is off limits. We can't touch anything inside the absolute value. Okay, so that's, we're just going to try to get it by itself. And you already told me the steps. We add 1 to both sides. And then what's inside, remember I think on the Friday before conference week, we actually just said, let's just call that a U to remind us that it's untouchable, right? It's not, that we can't do anything with it. So the absolute value of whatever's inside, just call it U. Then we divided both sides by 2. And we got the absolute value of U equals 6, right? Now what's our rule? If we've got the absolute value of something is equal to a number, what's the change that we make?
4 and then negative 6.
Okay, good. So here's where we're going to split this into 2 regular equations. Once we've isolated, we're done with part 1. We did it. We isolated the absolute value. Okay, next step. Step 2 is we're going to take this statement. If the absolute value of, we'll call it U, is equal to some number, let's just call it K. Doesn't matter. I'm just making up symbols here, but it's just some number K, then that's equivalent to the 2 equations, either U equals what? If this is some stuff inside the absolute values, that's what we're calling U. And if K is just the number, that's just a number that's outside the absolute values. What are the 2 equations I get? Either U equals K, or, and that's just our fancy way of saying or, what? U equals negative K. That's it, right? Piece of cake. So then all we're going to do is we're going to make this trade right here, right? We can say, okay, well, if that's true, then we get either U, and what is U? U is x plus 3, right? So then either what's inside, which is x plus 3 equals 6, or U equals negative 6. And then we just solve, right? From there, it's easy. What's the one step I have to do to isolate x in both cases?
Minus 3.
Subtract 3. So either I'm going to get x equals 3 or x equals negative 9. Right, so that's our answer. Okay, no big deal. All right, what if, we're just going to throw out a hypothetical here. What if we had gotten the absolute value of U equals negative 6?
It would be 6, right? Or negative 6.
No, the algebra, you could do algebra on that, but you got to pause and think here for a second. You always have to ask yourself, okay, does this make sense? Think about an absolute value. No matter what number I end up getting inside the absolute values, what's going to be the outcome? What's the output of an absolute value? What's the absolute value of any negative number?
No.
Positive, right? What's the absolute value of 0?
0.
There's no way to get a negative answer, is there? Right? So if that were the absolute value of U equals negative 6, what's your answer?
No answer.
No solution, right? There are no solutions to that. Okay? Wouldn't work. Okay, how about something like this then? So the next step, this is no harder, trust me. It's exactly the same level of difficulty when we move this on to inequalities instead of equations. There's just two other relationships like this one, right? Here's one of the relationships that we had to remember right here. Okay, that's for equations. If we get the absolute value of u equals k, then this is the trade that we make, right? The only thing different about this problem is now we've got an absolute value of u is less than some number instead, right? Just a different relationship, but we're going to make a trade, same kind of a trade, right? Okay, so everybody agree that in this case, part one is already done. The absolute value is already isolated. Right? Everybody agree? Okay, we've already got it's already done. Okay, we don't have to do anything to get it by itself. So we'll call what's inside u, and if I have the absolute value of u is less than k, what do you think the trade's going to be here? What's the equivalent statement we can make? How are we going to get rid of the absolute values? Either, what's going to happen? What about that u? What do you think?
They're gonna be negative.
Yeah. So u has to be what? If the absolute value of u is less than k, think of an example. Like what if k is 7? Well, 5 would work, wouldn't it? And negative 5 would work. And 0 would work. Or 1 or negative 1. What about 10? What about negative 10? No, it wouldn't, would it? So the size of the number has to be less than k, positive or negative, doesn't it? See what I'm saying? One way to think about it. We went through, who was here on the Friday before conferences? I know we had a lot of people missing. But if you were here, remember we drew the B's and then we looked either above or below the B's, depending on, and if you haven't seen that video, even if you did and you feel like you need to review it, go back and look at that video. That's one of the few all year that I should say about everybody ought to probably go back and just breeze through that one and take a quick look at it. So does this make sense then? If u has to be, 10 was too big, negative 10 was too small, but if this was a 7, like negative 5 or 5 was fine, negative 1 or 1 was fine, 0 was fine, isn't that telling us that u has to be greater than negative k and less than positive k? Everybody agree?
Good.
That's what's going on. So that's the trade we make if we have a situation like this. If the absolute value of u is less than a number, then u is going to be trapped between negative the number and positive the number. So what's that going to look like over here then? This is our u, right? Right? So what's inside the absolute values is our u. So what about it? What's it got to be? Willie, what's it going to be then?
I'm not really sure.
Okay, so what if that worked out to be, I picked an x, so I got a 38 in there. Would that work? Is the absolute value of 38 less than 36? No, right? Too big, isn't it? 38. What about 33 would work though, wouldn't it? Or 35? What about negative 35?
Yeah.
Sure, because it's an absolute value, right? What about negative 38?
Yeah.
No good, because the absolute value of negative 38 is 38, which is not less than 36, right? So this is the same kind of pattern, isn't it? What's inside has to be trapped between what values?
K and K. Okay and negative K.
Okay, so what's going to be over here? It has to be greater than,
Negative K.
which is just negative 36, right? And less than positive 36. Everybody see that? Because this is like my u, right? U is what's inside, and this is like my negative k and my positive k, right? Everybody see that? That's the pattern we follow. Now what? Well, now it's easy. Now all we have to do is just solve that compound inequality. What are the steps to get the x by itself?
Minus 33.
Subtract 33 from everything, right? So there's the first step. That gives me 3x in the middle, negative 36 minus 33. What's that? Okay, negative 69, 36 minus 33. Positive 3. And do I have to flip the inequalities there?
No.
No. What's the only time I flip the inequalities?
Divide by negative.
Divide by a negative or multiply by a negative also. Usually we're dividing by a negative, but either one would work. So they stay the same. What do I do now?
Divide by 3.
Divide everything by 3. So those cancel. I got an x. Negative 69 over 3 is negative 23. I don't flip that because I divided by a positive. 3 over 3 is 1. So there's my answer. All the values of x greater than negative 23 and less than 1 will work. Okay. Once again, the part that you got to remember is this part. If the absolute value of something is less than a number, then what's in the absolute value is going to get trapped between the negative of the number and the positive of the number, right? That's it. And then we just solve whatever we get from that. Okay, simplify. Okay, how about this one? Same kind of thing. Got a little bit of work to do here. Okay, is the absolute value isolated?
No.
What's the one thing I have to do to get that absolute value by itself?
Divide by negative.
Divide by negative 4, right? 'Cause it's being multiplied right now. So if I divide each side through by negative 4, that's going to cancel the negative 4. So I'm going to get the absolute value of 3x minus 27. Over here, what's negative 36 divided by negative 4?
So that's 1.
Positive 12.
Positive,
8.
I heard it somewhere.
8.
No,
9.
9, yeah. 9 times 4 is 36, right? Okay, but what do I have to do? I divided by a negative, so what's that mean? Gotta flip the sign around. Good, so the sign ends up being a greater than or equal to. Okay, so then this is like my u, isn't it? Right? So here I've got something of the form absolute value of u is greater than or equal to some number, call it k. So what do you think is going to be the result this time? Let's try some examples. What if, so we have a 9 here, right? What if I pick an x so that what's inside is a 10? Does that work?
No.
Is the absolute value of 10 greater than or equal to 9?
Yes, actually.
Yeah, 10 would work, wouldn't it? Would 100 work?
Yeah.
Yeah. Would 5 work?
No.
Would 8 work?
No.
No. Would negative 8 work? No. Would negative 10 work? It would. Negative 100 would work. So this time we're looking for values that are bigger than this number, either in the positive or negative direction. Those are the ones we want, right? So what's our trade going to be then? So this thing is going to trade for either u is going to be greater than or equal to positive k, right? Does that make sense? Like if it's a really big number, then yeah, its absolute value is going to be greater than or equal to k. Or u is going to be what? Less than or equal to what? Negative k. Okay, so there's our trade in this situation, right? If I've got an absolute value of something is greater than or equal to a number, then I'm going to make a trade for an or compound inequality. Okay? So what's that look like for us then, over here? So what's that going to be? How am I going to say this? So what's inside is u. So there's what's inside. 3x minus 27 has to be what? What's it going to be?
Greater than or equal to.
Greater than or equal to, good.
9.
Yeah, 9. There's part of it, right?
Yeah.
Or what's inside, so there's my u,
Okay.
is going to be what?
Less than or equal
Less than or equal to
to negative.
-9. Great. Easy, right? All I got to do is solve those. That's no big deal. Just add 27 and divide by 3, right? If I add 27, I get 3x is greater than or equal to 36. Divide by 3, what do I get? X is greater than or equal to, what's 36 divided by 3?
12.
12. So there's one possibility. Either x is greater than or equal to 12, or what about over here? If I add 27, I get 3x is less than or equal to 18. If I divide by 3, what do I get?
6.
6. So there it is. Either x is greater than or equal to 12, or x is less than or equal to 6. Okay? Make sense? Okay, go to it. Do some work.